Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about biomolecule synthesis. This is an interesting biomolecule. And the question is in front of you. You have to say that what is the major product of this reaction. 4 options are provided and one of them is the right answer. So you have to say which one is the right answer. Okay, I believe that you should try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time I'll give you the right answer with proper mechanism. I believe you have tried by yourself. It's my turn to give you the right answer. Now this molecule is apparently look little bigger, but it is actually not. Second thing, I suggest you student, please read the condition carefully. This condition reading will give you the answer. Triphenyl phosphonium bromide, what is this reagent? You can consider that triphenyl phosphine plus HBr. Like if I say tributyl ammonium bromide, if I say, then what you can consider? That it is tributyl amine plus HBr. Simple. So it is actually acid adduct with phosphorus. Okay, and remember this ammonia is harder base, but phosphorus is softer in nature. That's why phosphorus doesn't like proton that much. It likes softer in nature like carbon. Okay, so in this way I mean that it is actually HBr and triphenyl phosphine is added in the reaction medium. Now HBr is actually student hard acid, means it releases proton, and where the proton is expected to go. Obviously you can see you can see here that proton will prefer to go to the harder center, and here this OH is harder in nature, so it will be protonated to form OH2 plus. And next stage, see if this part leaves, what it will produce? It will produce a carbo-cation with both tertiary and allylic. So this is more specifically, it's doubly allylic. So this side it's also allylic, from this side also allylic. So it's a highly stable cation. So let's go from this beginning, and you can see the first step temperature. Reaction is so much facile that -10 to room temperature this thing happens. Okay, so let's look at the mechanism. So first it's protonated and produces this carbo-cation, as I told, tertiary as well as allylic at this milder condition, and THF is solvent here. Next step, there is a resonance. Lots of resonance possible student involving this side, but I am not going because that do not have any fate. Compared to that, if you go this part, it will produce this, and in this case it is a primary cation. Now student, if you think that why I didn't focus this side, so if it is, this is also a tertiary carbon, so actually not effective. So that's why we shall focus this side. Now, so it is actually a carbo-cation, and if you look at tertiary carbo-cations are more bulky. So they are more bulky, means nucleophile can't approach them easily. So nucleophile can't approach them, but if it is primary, then nucleophile can approach here easily. It's true. That's why exactly that thing happened. Now here this triphenyl phosphine is softer in nature, so it attacks here. Now student, you may think that sir, in this case why bromide didn't react? Bromide is also a good nucleophile. It's true that bromide is a good nucleophile, and let's consider that it produces the C-Br bond also. Then in the next step, in the reaction medium there is triphenyl phosphine. We know that triphenyl phosphine is good nucleophile and Br is good leaving group. So this PPH3 molecule with this lone pair can attack here and it can leave. So ultimately the fate is same. So that's why I suggest you don't bother that why bromide, why you didn't write the bromo, because ultimate product is this one. Okay, and after this attack, after this nucleophilic attack, this phosphorus is expected to carry a positive charge because it's attacking from its lone pair neutral molecule, and bromide will be the counter anion here. Now if you look at this, this is student allylic system, and there has proton, and if you treat this thing with phenyl lithium, in this case phenyl lithium act as base. So what it does, this carbon ion from phenyl abstract this proton and it produces one carbon ion here. So this is, and this part is called student ylide. Now I suggest you please recall the Wittig reaction. Okay, so this is ylide, and here I shall say it is stable ylide. And remember student, this stable ylide always result trans. Okay, so this stable resulted in trans, and in this case this stable ylide, and ylide is actually student nucleophilic in nature, and it reacts with the electrophilic center like aldehyde. Means it act as you may consider that nucleophilic addition reaction happened. So this is a double bond, and these carbon ion act as nucleophile attacks here and ultimately opens up through a 4-member ring rearrangement. It ultimately converted into these carbonyl. I would say student, in this case this carbonyl oxygen is got removed and there one carbon comes. So actually this Wittig reaction is a conversion of carbonyl into alkene. Okay, I've already discussed many lectures on this concept and complete mechanism. Please visit those lectures. I shall provide the link in the description box. I am not going to explain because it will be too much complicated, big molecule. So, and second, in Wittig reaction, alkene is produced. Whether cis or trans, as I told, since the Wittig reagent is stable, this stable Wittig resulted in trans alkene. That's why this double bond is trans. Actually, student, if you look at that, I'm extremely sorry that not this double bond, because this double bond was there at the beginning. This double bond is produced. Okay, so this double bond is produced because third carbon with respect to this methyl, so 1 2 3. So this double bond is produced, and this is actually trans in nature. Okay, and if you look at, so it's a conjugated system. You can consider that from here this is 1 double bond, 2 double bond, 3 double bond, 4 5 and allyl acetate, because I have taken the acetate thing. So this is the product, and actually this is the product of this overall reaction. So if we look at this problem based on key steps and name reaction, first step is the elimination of allyl alcohol by acid, this HBr, under very much milder condition to produces both this tertiary cation and primary, and nucleophilic addition happens on this primary carbo-cation because it's less bulky. So this is phosphonium salt is produced. It reacted with this phenyl lithium, means Wittig reaction for transalkene preparation, as the Wittig reagent or ylide is stable. So ultimately this conjugated molecule is produced. So, and remember student, in this case just one concept, phosphorus oxygen bond forms, because from ylide it produces this triphenyl phosphine oxide, and this phosphorus oxygen bond formation is the driving force for this transformation, means this alkene, this carbonyl to alkene transformation. Now, so what is the answer of today's problem? Today's problem answer is student, just here one interesting point, carbo-cation will be here, so no additional carbon is coming. So here if you look at up to this, so from here how many, 1 2 3 4 5 6, and in this case I am talking about chain 1 2 3 4. So here actually from 6 and 4 10. So 10 how many, let's look at here. So if it is 1 2 3 4 5 6 7 8, not 1 2 3 4 5 6 7 8 9 10. So this is one. Last part should be acetate because we have taken acetate here. Now another thing is that everything should be trans double bond. So this is the answer. Now student, if this problem appears in your exam, how can you come to right answer less than 1 minute? Here I shall not say 30 seconds because it's relatively difficult, I agree. In this case student, first you need to understand that what is the role of this reagent. This is actually HBr phosphine combination. So this is elimination will occur and nucleophilic attack will happen from the less bulky side. So that thing you should write first, and if you are able to write this thing, instantly you can understand that actually this is a Wittig reaction, this is an carbonyl, and here in presence of phenyl lithium this ylide is produced. So a simple Wittig reaction will happen and transalkene. And how many carbon? As I showed here the counting system, so please count with cool mind slowly, and here it will be the right answer. So no tricks for this one, okay, and these are the reference of this problem. Now in conclusion, what you have learned today, that allyl alcohol are prone to undergo protonation followed by dehydration, as the resulting carbo-cation is highly stable, because through plus I and plus R effect. Now less bulky carbo-cations are preferentially attacked by nucleophile because of it means steric repulsion, steric crowding, steric factor. Triphenyl phosphine are better nucleophile due to its softness of the phosphorus atom and its lone pair. And phosphorus ylide undergo Wittig reaction to produce alkene, and here phosphorus oxygen double bond production means triphenyl phosphine oxide production is the driving force of this reaction. Remember, stable Wittig reagent means here obviously the conjugated carbonyl is stabilized because of the conjugation with the double bond. So stable Wittig reagent or this phosphorus ylide result in predominantly trans alkene. And remember student, vitamin A is fat soluble vitamin due to its hydrophobic groups present. Now let me take about you to vitamin A. So what is vitamin A? This is student retinol or vitamin A. I am talking about this structure. So just look at how many carbon we have concluded from here, means numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just this one, sometime before we told that it was OAC. If ester hydrolysis is done, this OAC means, if you look at this OAC means it's an acetate ester, simple if you look at. So this is double bond OCH3. So this ester hydrolysis, more specifically if you can say it's an under allylic condition, so it will produce, means alkaline condition, it will produce this alcohol, this allylic alcohol, and this is called student vitamin A or retinol. Look at this OL word, nol, OL. Why? Because it has this alcohol. Now if you look at this molecule is pretty big, lots of carbon are there, it's a conjugated, and another thing, it's hydrophobic. Why? Because see, all the carbon, only one hydroxyl group is there. With respect to so many carbon atoms, only one hydroxyl group is there. So you can expect that this molecule is fat soluble. So that's why you say that vitamin A, D, E, K is fat soluble, means this is vitamin A, this is fat soluble. Why fat soluble? Because of this carbon chain and only one OH, means it doesn't contribute that much, that's why it is fat soluble. In contrast, if you look at vitamin C, there are many hydroxyl groups. I have already discussed about this vitamin C in dedicated lecture, please visit and compare their chemical structure, then only you can understand why vitamin C is water soluble whereas vitamin A is fat soluble. So this is the end of discussion. I believe this video may be useful, and if you really consider my contents unworthy, then please help this channel to grow. So thanks for watching. See you in my next video. Bye bye. Take care.